Yeah, let's have an example of applying superposition theorem in analyzing a circuit. Okay, we have here a circuit and we need to find the value of I. Since there are three sources, we need to find three values of I. First, we need to solve for the value of I using the 12-volt source or using this source. Okay, as you can see, the 8 ohms and the 4 ohms resistor are connected in series and connected in parallel with the 4 ohm resistor. So to solve for R, we'll have 8 ohms plus 4 ohms in parallel with 4 ohms. 8 plus 4 is equal to 12. So 12 times 4 divided by 12 plus 4. The value of R is 3 ohms. Then redrawing the circuit, we now have 12-volt source in series with the 3 ohm resistor and the 3 ohm resistor. So, to solve for the value of I1, we will just apply KVL to the circuit. So, we have 12 minus 3I1 minus 3I1 is equal to 0. Okay, simplifying the equation, we now have 12 minus 6I1 is equal to 0. Then, I1 is equal to 12 over 6. Value of I1 is 2 amperes. Next step is solving the value of I using the 12-volt source. So this is now the circuit. Then we can use mesh analysis to solve for the current I2. Okay, so for loop 1, we have negative 24 since it is plus to negative, minus 8IA, minus 4IA, minus 4IA, minus IB is equal to 0. Simplifying the equation, we now have negative 24 minus 12IA minus 4IA plus 4IB is equal to 0. Then, simplify again. Negative 24 minus 16IA plus 4IB is equal to 0. Then we can further reduce it to negative 4IA plus IB is equal to 6. And we will now let it to equation 1. Then at loop 2, we have negative 4IB minus IA minus 3IB is equal to 0. Then distribute negative 4IB plus 4IA minus 3IB is equal to 0. Then simplify. We now have 4IA minus 7IB is equal to 0. Then finding an equation for IA. IA is equal to 7 over 4 IB. Next is, we will substitute equation 2 to equation 1. Since we need to solve for I2, then I2 is equal to IB. So substituting equation 2, we now have negative 4 times 7 over 4 IB plus IB is equal to 6. Then simplify. is negative 7 IB plus IB is equal to 6. Then the value of IB is equal to negative 1 amperes. Then it is equal to I2. So the value of I2 is negative 1 amperes. And next is using the 3 ampere current source. The circuit will become, the circuit will look like this if you will use the 3 ampere current source. So for this circuit, we can use nodal analysis. Then at node 1, since it is nodal, so at node 1, so we have current entering. So it is V2 minus V1 over 4 is equal to V1 over 4 plus V1 over 3. Then simplifying the circuit, we can multiply 12 to both sides. So multiplying 12 to both sides, we have 3V2 minus 3V1 is equal to 3V1 plus 4V1. Then combining like terms, we can have 3V2 is equal to 3V1 plus 4V1. Then transposing negative 3V1, we have 10V1. Then V2 is equal to 10 over 3 V1. Then label it as equation 1. Next is at node 2. So at node 2, we have 3 amperes is equal to V2 over 8 plus V2 minus V1 over 4. Then to simplify, we can multiply both sides by 8. So 8 times 3 is equal to 24. 8 divided by 8 is equal to 1 multiplied by V2. So we have V2. Then 8 divided by 4 is 2. So we have 2V2. 8 divided by 4 is equal to 2. Then negative 2V1. Simplifying, we now have 24 is equal to 3V2 minus 2V1. Then label it as equation 2. Then to solve for V1, we will just substitute equation 1 to equation 2. So we now have 24 is equal to 3 times 10 over 3 V1 minus 2 V1. Simplify, we now have 24 is equal to 10 V1 minus 2 V1. Then 10 V1 minus 2 V1 is 8 V1. Then 24 divided by 8 is equal to 3 V1. Okay, in this circuit, I3 is equal to V1 over 3 ohms. So to solve for I3, so you have V1 over 3 is equal to 3 volts over 3 ohms. The answer is 1 amperes. Then to solve for I, we will just sum up the values of I1, I2, and I3. So the value of I1 is 2 amperes. Value of I2 is negative 1 ampere. And the value of I3 is 1 ampere. So 2 minus 1 plus 1 is equal to 2 amperes. Therefore, the value of I is 2 amperes.